Christensen, Lostson, Olson. Cite this. JMed. Chem. 2020, 63, 13709-13718. Read online. Access metrics and more article recommendations *. See supporting information. Abstract. Venomous snakebites cause greater than 100,000 deaths every year, in many cases via potent depression of human neuromuscular signaling by snake alpha neurotoxins. Emergency therapy still relies on antibody-based antivenom, hampered by poor access, frequent adverse reactions, and cumbersome production purification. Combining high-throughput discovery and subsequent structure-function characterization, we present simple peptides that bind alpha-cobrotoxin, alpha-CBTX, and prevent its inhibition of nicotinic acetylcholine receptors, NACRs, as a lead for the development of alternative antivenoms. Candidate peptides were identified by phage display and deep sequencing, and hits were characterized by electrophysiological recordings, leading to an 8-mer peptide that prevented alpha-CBTX inhibition of NACRs. We also solved the peptide, alpha-CBTX co-crystal structure, revealing that the peptide, although of unique primary sequence, binds to alpha-CBTX by mimicking structural features of the NAC binding pocket. This demonstrates the potential of small peptides to neutralize lethal snake toxins in vitro, establishing a potential route to simple, synthetic, low-cost antivenoms. Introduction. Snakebite envenoming kills or maims hundreds of thousands of people every year. 1, 2 And loss of livestock is also emerging as a substantial problem. 3. 4-6 There is therefore an urgent need for novel treatments and new strategies. 7, 8 In the case of elapid snakes, such as cobras and kraits, three-finger alpha neurotoxins such as alpha-cobrotoxin, alpha-CBTX, and alpha-bungarotoxin, alpha-BGTX, are the most prominent and lethal venom components. 9-11 Alpha-CBTX and alpha-BGTX potently inhibit postsynaptic nicotinic acetylcholine receptors NACRs, which depresses neuromuscular signaling, causing paralysis and loss of respiration. 12 The effectiveness of conventional antivenoms is limited by immunogenicity, abundance of alpha-neurotoxin antibodies in the immunized animal at the time of production. 13 And which type of snake inflicts the bite. Newer antibody-based strategies have emerged, with a focus on smaller, less immunogenic, and venom-specific antivenoms. Smaller camelid antibody fragments raised against cobra venom were shown to neutralize the effects of alpha-CBTX in mice and may allow for greater tissue penetration than conventional antivenoms. 14 Phage. Display of a library of human-derived antibody single-chain variable fragments against alpha-BGTX from krait venom led to one fragment that neutralized toxin injected into mice. 15 In the future, combinations of such lead entities could enable development of safe and effective treatments, as reflected in the recent application of cocktails of human monoclonal antibodies targeting mumba toxins. 16 These showed promising neutralization of dendrotoxins in mice, although some improvement is needed in neutralizing alpha neurotoxins. As an alternative to antibody-based strategies, we sought to discover short peptide-based neutralizers of alpha-CBTX by screening phage display peptide libraries for alpha-CBTX binders. Hits were then tested for neutralization of alpha-CBTX inhibition of nicotinic NACRs using electrophysiology. This led to the identification of an effective 8-mer peptide, for which we solved the peptide, alpha-CBTX X-ray co-crystal structure, revealing the detailed binding mode. The identification and characterization of short peptide neutralizers of alpha-CBTX could lead to the development of targeted, fully synthetic, next-generation antivenoms for snakebite envenoming. Received. July 21, 2020. Published. November 4, 2020. pubs.axe.org/JMC article. Copyright 2020 American Chemical Society 13700 doi.org/10.1021/axe.jamedchim.oco1202. Org 10.10 Jamedchim.0 J. Med. Chem. This is an open access article downloaded via 1 CHTT axe.org/org Key values for peptides 1 and 12 determined by inhibition of 9 binding to C after 5. Each peptide. Journal of Medicinal Chemistry Pubs. ax.org/jmc. Jamedchem points. Chem. Additionally, deep sequencing of phages from all rounds identified 6 additional prevalent peptides, 3-8, that were also considered further. Table 1, see experimental section. Characterization of peptides with YM motifs that modulate alpha-CBTX inhibition of nicotinic acetylcholine receptors. We next tested these binders for functional modulation of alpha-CBTX activity in electrophysiological assays. We heterologously expressed nicotinic alpha-7 homomeric NACs in Xenopus laevis oocytes and measured acetylcholine-gated currents in response to acetylcholine alone, in the presence of alpha-CBTX, or in the presence of alpha-CBTX preincubated with the identified peptides. As expected, alpha-CBTX alone 40 nanometer inhibited NAC responses to 10% compared to the control level, and among the 6 additional binders, peptide 3 prevented alpha-CBTX inhibition of NACs comparably to 1, figure 1b. However, peptide 4 showed no effect, figure 1b, and peptides 5 and 6 were poorly soluble and could not be tested. Curiously, peptides 7 and 8 enhanced both the onset and the washout of alpha-CBTX inhibition of NAC. EPEG, polyethylene. ax.org/j. We the https://dx.doi.org/10.1021/ax.jamedchem.oco1202. This raises the possibility that the mechanism of alpha-CBTX inhibition by 12 involves inducing toxin dimerization. There is very little contact between the two alpha-CBTX molecules themselves in the complex 52. We therefore tentatively conclude that the simultaneous binding of 12 to 2 alpha-CBTX molecules leads to a mutual stabilization of both interfaces or that peptide 12 blocks. However, analysis of 12-induced dimerization of alpha-CBTX in solution by size exclusion chromatography was not possible due to the high hydrophobicity of the peptide, which led to aggregation on the gel filtration column. Although by two different YM B magnified view show E binding mode B key interacting residues drawn as in B. ax.org/jmc article. https://jamedchem.0 Chem 2020 63 13709-13718. Exchange of this tryptophan for a tryptophan residue that precedes the YM motif also interacts with alpha-CBTX F65 at the stem. The key residue alpha-CBTX R33 that has been implicated in